Hi, I hope you're having a good day. This is a quick video on indices and the rules of indices. So, an indice, also known as a power, is written as a to the b. So this could be 5 to the 2, for instance. It could be 3 to the 7. It could be whatever number you want to the power of another number. And so this is said as a to the power of b, or a to the b. People say it in different ways, but that's usually what they mean. Okay, so what does a to the power of b even mean? So it means a multiplies with itself b times. Okay, for instance, I've got 5 to the power of 2 means 5 times itself 2 times. 2 to the power of 4 means 2 times itself 4 times, as you can see on the right here. 3 to the power of 7 means 3 multiplied with itself 7 times. And as you can see, 1, 2, 3, 4, 5, 6, 7. Okay? And then you just figure out what these are and you can write them down like that. Now, indices have a few rules and they are pretty much all to do with how you can combine them. So on the left, I've written them out and I'm going to do examples for each one and go over some common misconceptions. So if you have x to the a times x to the b, when you combine these, the powers add. Now, what I forgot to mention is these bottom numbers are called bases and the tops are called the powers. That is not as useful to know, although you do need to know one thing. The bases must be the same for you to combine them. For instance, I can do 5 squared times 5 to the 3. That will be 5 to the 2 plus 3, which is 5 to the 5. But I could not say 2 to the 2 times 5 to the 3. This is not equal to 2 times 5 to the power of 2 plus 3. You can only combine these terms if the bases are the same, okay? This applies to letters too. X to the a times y to the b is not equal to xy to the a plus b. In this case, this is the simplest you could write that. You cannot combine anything, okay? Unless x and y were the same letter. So the next one follows that same rule of the bases have to be the same, but when you divide, instead of adding the powers, you take away the second power from the first. Okay? For instance, 5 to the 5 divided by 5 squared is 5 to the 5 minus 2, which is 5 to the 3. And interestingly, if I do 5 squared divided by 5 to the 4, I will get 5 to the minus 2. So you can have negative powers, and I'll go into that later. So, the next one here is when you have a power to another power. So, for instance, I could have 2 to the 3 to the power of 2. In this case, you multiply the powers. This would be 2 to the 6. But the reason that happens is because, for instance, this one here is 2 to the 3 times 2 to the 3, which is 2 to the 3 plus 3, which is 2 to the 6. So you're basically adding that power to itself this number of times, which is what multiplication is. Okay, so the next fact is that any number to the power of 0 is 1. So 5 to the 0 is 1, 2 to the 0 is 1, 1032 to the 0 is 1, any number to the power of 0, and any letter to the power of 0 also. Because letters are just placeholders for numbers, really. And then here we go into the negative bit. So I don't know if I mentioned before, but the reciprocal of a number is that number flipped, essentially. So I'll give an example to explain what I'm trying to say. So you see x to the minus 5. You now have that x to the 5, and it's on the bottom. In fact, I'll quickly go into what reciprocal is. So reciprocal of, say, AB is B over A, okay? The reciprocal of 3 over 7 goes to, so these things are not equal, I'm just trying to show what happens when you reciprocate them. It goes to 7 over 3, okay? So you might be thinking, what is the reciprocal of a whole number? Okay, so let's say 3. What does that go to? Well, any number in the world is equal to that number divided by 1. So sometimes if you want, you can write a 1 underneath a whole number because it's equal. Because if you divide something by 1, it doesn't change it. And now you can see that will go to 1 over 3. So in general, if you have a whole number, like, I don't know, 5, the reciprocal will go to 1 over 5. 7 would go to 1 over 7 because of that pretty much hidden 1 underneath the number. Okay, so this is an important one to remember. You don't see it too much, but it is still important. And this last one is probably the most difficult to understand at the start, so I'm going to move it down here so we can see it a bit easier. So x to this fractional power means x to the power of a and then rooted by b. Okay, so if you haven't seen square roots or cube roots or any number root, you could have an nth root, then I would recommend having a look into what they are. But for now, I would just give an example, and I might do a video on roots later. For instance, x to the 2 over 3 means x squared and then cube rooted. Let's do this with a number. Let's say, let's do 2 to the power of, let's do 8 to the power of a third. That'll be interesting. Okay, so this means 8 to the power of 1, and anything to the power of 1 is just itself, so it's just an 8, and then it's the cube root of 8, which is 2. Okay, 4 to the 3 over 4 means 4 cubed to the 4th root, and 4 cubed is 64. Okay, so that pretty much covers everything you need to know on indices. Just try to remember the rules here. I'll scroll so they all get in here, and you might be able to fit it, screenshot it, whatever you want. But remember these, and remember these things only combine when the what are called bases are the same. So don't combine numbers that are different, like I did the example here where I did 2 to the 3 times 2 to the 5. This is times 5 to the 5. This is not equal to some sort of 2 times 5 to the 8. These numbers must be the same for you to combine them, okay? So that just about covers it. Have a great day.